So first, if you want to work with Docker, first you need to create instance. After that, install Docker on particular machine. So after installation Docker engine, this server, our application is going to deploying as a containers. So what is mean containers and what is meant by images? So we need to understand. See here, what does Docker images contains? So Docker images, main use case of Docker images and what it is contains. So here Docker image base operating system. Docker image often start with base image that include a minimal operating system, such as Ubuntu, Alpine, Debian. So, and second one, application code. So, what are the what are the requirements of our application? We need to customize by using this base OS. So, the image contains the code of application you want to run. So, for this application, what are the dependencies we need? So all necessary libraries, frameworks, and other dependencies required for the application to run are included in the image. So image itself, you can, based on while building image, you can understand these all how to build how to install libraries from external source. For that we need to use specific instructions. So we'll work on this. Next, environment settings, configuration files and environments variables that necessary for application to run. Scripts, any scripts required to start, stop application or performing other applications. So also Docker image contains metadata, information about image such as its name, tags, the command required to start the application. So clearly understand. Docker image contain base OS, application code, dependencies, environment settings, required scripts, and metadata. All is a part of Docker image. These are necessary Docker image. So we need to understand purpose of Docker image. Consist. This is the one use case of Docker image. Docker image ensures that the application runs consistently across different environments. That may be development, QA, UAT, or non-prod production. Like this, based on organization, whatever environments they are managing for on infrastructure, all necessary environments, Docker images and ensure that application runs consistently across all different environments. That is the consistency of Docker image. Next, portability. Application can be easily moved one operating system one system to another without worrying about compatibility issues. This is this is a major advantage, compatibility. So there is no specific OS dependency. It is a portable. Once image created, we can run any OS that is saying. So isolation. Next, Docker image provide isolation, which allows you to run multiple instances on application or different applications simultaneously on same mission without interference. So this is the isolation part of Docker image. Reproducibility. The application will always run same way, regardless of where it is deployed. This is the reproducibility. Efficiency. Docker image can be op optimized for size. So easier to manage, store. So this comes under efficiency. So purpose of Docker images means consistency, portability, isolation, reproducibility, efficiency. Like Docker images, Docker image use case. So purpose of Docker image application deployment, deploying consistent and efficient manner across different environments. Already you said that different environments means development, QA, UAT, non-prod, production, like that. So it completely depends on microservices based architecture. So if you want to maintain zero downtime, so high availability features you need to achieve by using container architecture is very useful when you are choosing microservices architecture. In separate Docker containers, each based on its own image. So we can customize based on our requirement. In the microservices architecture, we need to create our customized images. Deployment and testing, providing consistent development and testing environment for developers, regardless of their local setup. So on-premises deployment in development environment and testing environment, they're managing infrastructure and locally. So this is the regardless their local setup. Continuous integration and continuous deployment. Automating the deployment of applications by building Docker images and deploying them through a CI/CD pipeline. By using CI/CD pipeline, you can deploy the applications in multiple environment. As per the DevOps roles, you can build pipeline. So like that, continuous development, continuous testing, continuous integration, and continuous deployment, configuration management, and continuous monitoring. These are the live deployment of pipeline. Software distribution, packaging and distributing software as a Docker image specified the process of sharing and deploying application across different platforms. Next, scalability. Quickly spinning up new instances of the application using Docker images to handle increased load. This is the scalability. We can scale up, we can scale down by using this feature, Docker images. So legacy application moderation. We can migrate old monolithic architecture to container architecture, entire architecture, and agile applications. Process of application is using agile architecture. So we need to deploy these applications to container architecture. So this is the legacy application modernization. Containerizing legacy applications to run them more efficiently and consistently across environments. So these are all about Docker image. So now we discuss about container. What is Docker container? So running application. The application defined by the Docker image, including its code dependencies scripts. So Docker image is a package. After running application, you consider as it is container. So file system. The container file system is based on the image but can be modified while the container is running. Any changes are isolated to container. This, this is completely depends on container file system. So networking configuration. Containers can be configured to interact with other container. So when you discuss about container networking, Docker networking, we need to understand these containers can be configured to interact with other containers and external networks. So you have multiple networks in your Docker cluster. You need to configure based on our requirement. That is the network configuration of containers. Resource limits. Containers can be assigned resource limits, CPU, memory, control their impact of host system. So if you don't want to provide this kind of assign resources limits, so some cases, some content occupy whole system. So that is consumed whole hardware. Means other containers are not able to run because so while creating container, there is memory CPU space. So that is the main. So in that case, we are using resource limits. By using the limits, we can control how much GB RAM if you want to, this container want to consume, how much CPU this container want to consume. We can decide. This kind of flexibility is there when you go for containers. So environment variables can be set at runtime control aspect of application. Its environment means is a DB kind of applications or any web server. So definitely we need environment variables. So that case we are using environment variables. So Docker containers main purpose. So isolation. This is the one use case. Container run applications in isolation from each other and from the host system. Portability. Containers can be easily moved and run on any system with Docker installed. So once Docker installed any system, we can move one system to another system, it is saying. That is nothing but portability. Consistency. Containers run the same way across different environments such as development, testing, production. Scalability. Containers can be started, stopped quickly, making them ideal of scaling of application based on demand. So based on demand, we can increase the load, we can decrease the load. Based on load, we can increase the containers, we can decrease the containers. That is nothing. That is scalability. Next, efficiency. Containers are lightweight because we have a lot of customizing features. Docker official images, you can take base OS as a lightweight container. Mostly preferable lightweight base OS, Alpine. So go and take the Alpine. You need to work on that base, customize on our application requirements. allow, allowing multiple instances on run on same host within minimal overhead. So, so this is the efficiency. This is about containers and a Docker image. Next, coming to Docker architecture. See, we have three components. One is Docker client, Docker daemon, and Docker registry. Docker registry is a, see, I'm opening, see, I'm sharing this. Docker Hub. Docker Hub is a, we can store images on remotely on the Docker Hub. Docker Hub. So here is the Docker Hub. Just click on this link. It's the Docker Hub. We have private repository options. One is private repository, another one is public repository. If you want to expose your images globally, so we will go for Docker public registry. If you, if you are using your own application images, you can store private repository, and you can store Docker registry in local repository also there. We can maintain local labels. So here client want, whenever user fire the command, so the command related to it, it, it is taking as a request to send to Docker daemon. So Docker daemon decides that this container, this request related to image or containers. So if it is image, so if image available is local or not, it is checking first. So if image is not available in local, immediately it is going to look for Docker registry. So it is finding, if you want to pull local, if you want to pull Ubuntu official image, so immediately, so it is pulling this image from Docker Hub, from local, from Docker host to Docker host. So that is, so each component working like that. See, Docker client, main purpose of Docker client. So whenever request came into this Docker host, immediately this client will interact to get this to get this request and send them to Docker daemon. So Docker daemon decides that this request is related to images or containers. If it is container related, so it will work on containers. So it is only you are pulling from only image from Docker Hub. It is going to pull image from Docker Hub. So that kind of activity, these components. So further classes we need to understand while working on pushing image after creating my image, how to push so image as a public registry and private registry. We understand further classes. So this is about Docker architecture. So mainly we need to remember Docker client and Docker. Docker. These are three components. And background they are using quorum algorithm. So quorum algorithm decides that is a API request. Each of request is a API call. So this is the one component. This is one component. If you want to component this component, we need API request. That is the background configuration, background software like that. So next, after creating Docker host, so I created one instance. So now in on go on access, click on connect. If you want to connect image, first highlight, then connect. Copy this ID, such client ID. So already I installed Mobexter my machine. So I'm going for my Mobexter means Mobexter is a portable software in different client client shells, Bash shell, CMD, and Windows PowerShell, VSL default, Ubuntu. Is there any o- remote Ubuntu machine installed in virtual Ubuntu? This one. It is saying install virtually Ubuntu in my local. That's why it's showing Ubuntu. When I click Ubuntu, it completely switch it to my law, not Windows. Switch it to Ubuntu machine. So if you want to connect Git or any other this SSH client softwares, to connect this mobile system software. Okay. Multiple clients we can connect by using this software. So session SSH, that provide public IP of the machine. Next, this is Ubuntu type Linux, Ubuntu based Linux. That's why Ubuntu advanced settings, provide key, API M file I am providing. So connect. Now connecting virtually by using SSH client. These servers are available in Scully from Napa, California region and with multiple availability zones. We are we, already we discussed this. So next, check once Docker installed or not. So Docker version or LB latest version already installed. Number roti we'll discuss but by default how to work on default with Ubuntu as Ubuntu user we can run Docker commands. That's also possible. So first switch to root user. How to switch root user you need to understand. Sudo su root. So this see previous user Ubuntu. Now we are in root user. Now find Docker images, list of images. This is the Docker command for finding list of images means already in the Docker host, is there any images or Okay. So, initially by using SSH, who provide public IP. Here Ubuntu name and advanced settings. Provide PEM key. Means while creating instance, it is asking key pair, right? Man Key pair is mandatory connecting remote servers. So after that, click on OK. Immediately came into this window. After installation Docker, see after update your machine. Next to install Docker on your machine. After that, fire command Docker version or Docker -v single -v. That is so checking version. So current Docker version is 26. So now I'm working with root as a root user. So check Docker images. Docker image. These are Docker commands. You need to by heart these commands. So there is no images. So if you want to pull images from global repository, means Docker Hub or your private location also. So Docker so here Docker pull Ubuntu pull. Try to pull again. So it is full complete. Click from library. So it is saying image. So how will find this images are present or not in the Docker Hub. So find image official image Ubuntu. This is the official image of Ubuntu. So by using this pull command, copy pull command and pull this image to your local host. And according to your requirements, you need to Dockerize. That purpose only you are using Docker images. So if you want different tags, means different versions, you need to add tag also. Colon latest. Here Ubuntu colon latest. You can use like this. Here tags. So Ubuntu colon rolling. Here Ubuntu noble. These are different versions. According to our requirement, we take we need one custom. Next, find DB related images. MySQL. This is the MySQL official image. Just pull this away, copy, go to your local host. Just right click. It is pulling from Docker Hub. publish out the images, Docker images. So latest, that means latest. If you want to, you know, while pulling it, Docker image automatically alt latest. So see, find here. It's a real OS means more than 8 GB plus. So they're providing very image, light images. This is also OS. That's why applications are very less consuming less resources and performing very well. That's why container technology is very popular. This is the main. Next. No, previously we were pulling Linux based OS image and database related image. Next, web server related image. We need to find Docker Hub. So HTTPD. This is the Apache. This official image is maintained by Apache community. So pull this image. Mostly PHP related applications deploying Apache not mostly, but they are using only it. So it is already available in local. That's why it is not remote. That's the amount of logs came. If the case is not present in local machine, so it is pulling some status pop-up. So next for deploying PHP-based application. And next, what type of? So Nginx is a reverse proxy server. So Nginx also is it for applications. Nginx. So find Nginx official image. So this is Nginx. List of images. We have 4 images. Now find document type DB. That is a MongoDB. So pull this MongoDB image. Document type DB. Previous MySQL is the relational database type. Next, find for catch image. We have pulled images. Yes. According to your requirement, you need to customize based on public. That those are DevOps engineer roles and responsibilities for building Docker images. Next, on different commands. Currently, we worked on Docker pull. Next, set kind of backtrace available image. So what type of specific tag you need, accordingly take that specific image. This is a combination of Ubuntu and MySQL. This is a combination of Ubuntu and Zookeeper. So you need to understand what is Zookeeper. So Ubuntu and JRE already Java installed packages in this image. Java runtime environment. So Ubuntu Postgres, Ubuntu Redis, Ubuntu.NET, ASP.ASP.NET. So Grafana, Cassandra, so Nginx, so Prometheus, Apache 2. So based on our requirement, you need to take this official images by, by using search command. Like every image, lot of images are there. Okay, go on, take them. After creating image, we'll work on this push command. So already we know list out the images. Next to Docker image inspector. If you want to know information about the image, Docker inspect image name Ubuntu. Inspect spelling mistake. So this is all about image information. See, this is the latest